welcome. This presentation provides a complete overview of the Hadoop Resource Manager, the core component of YARN's resource management system. We will explore its architecture, operations, and best practices to understand how it serves as the central brain of a modern Hadoop cluster. Here is our agenda for today. We will begin with an introduction to the Resource Manager and its role. Then, we will delve into its core architecture and components. We will cover the critical high availability setup, followed by how resources are allocated and scheduled. We'll discuss operational administration, monitoring through metrics, and conclude with industry best practices at a question and answer session. YARN, which stands for Yet Another Resource Negotiator, is the resource management layer of Hadoop. At its heart is the Resource Manager, or RM. It acts as the central authority, the ultimate arbiter of all resources in the cluster. Its key functions include scheduling applications, managing the application lifecycle, and monitoring cluster health. Its importance is paramount. A single resource manager is a single point of failure, which is why high availability is a non-negotiable feature for any production environment. To appreciate the resource manager, we must understand its evolution. In Hadoop 1.0, a single job tracker was responsible for both job scheduling and task monitoring. This created a severe single point of failure and limited scalability. Hadoop 2.0 introduced YARN, which elegantly separated these concerns. The Resource Manager now handles global resource management, while application masters, one per job, manage application execution. This separation allows multiple data processing frameworks like Spark, Tez, and Flink to run efficiently on the same Hadoop cluster. A table on this slide contrasts the two architectures, highlighting the RM's role, superior scalability, and ability to handle diverse workloads. Let's dissect the core architecture of the Resource Manager. It is composed of several key services. The scheduler is its most famous component, allocating resources to various applications based on configured queues and constraints. The Applications Manager is responsible for accepting job submissions and negotiating the first container for the application master. The Resource Tracker service handles registration and heartbeats from all node managers across the cluster. The Application Master Launcher then manages the process of launching that initial container. Finally, security is integrated through token secret managers, which handle authentication across the cluster. Beyond the core services, the RM relies on several internal components for robust operation. The client service handles all RPC requests from clients, like submitting or killing an application. The admin service manages administrative commands, such as refreshing queues. The node manager liveliness monitor tracks heartbeats and declares a node dead if it stops responding. The container allocation expirer reclaims resources if a container is not used by an application master within a timeout period. And crucially, the application master liveliness monitor does the same for application masters, restarting them if they fail, ensuring application resilience. Eliminating the single point of failure is achieved through a high availability architecture. This involves running two resource managers in an active standby configuration. The active RM handles all operations, while the standby is ready to take over instantly. Automatic failover is managed by a zookeeper ensemble, which conducts a leader election to promote the standby to active upon a failure. Administrators can also initiate a manual failover using the YARN RM admin command. For continuity, the state of the active RM is persistently stored in a state store, either in Zookeeper itself or in the Hadoop distributed file system. Configuring high availability is done primarily in the YARN site.xml configuration file. You must enable the HA property, define the logical IDs and physical host names for both the active and standby resource managers, and set the address of the Zookeeper quorum. A key feature for monitoring is the built-in health check endpoint. You can query the /is active endpoint on the configured RM addresses to determine which one is currently active, which is invaluable for scripting and load balances. This is the Resource Manager's primary function, allocation and scheduling. The scheduler allocates resources, packaged as containers, which are logical bundles of CPU cores and memory on specific cluster nodes. The process begins when an application master requests containers for its tasks. The scheduler then makes allocation decisions based on its policy, be it FIFO, capacity, or FAIR, and the available resources in the cluster. It's a continuous cycle of requests and allocations until the job completes. YARN offers a choice of schedulers to match different cluster philosophies. The capacity scheduler is designed for multi-tenant environments. It organizes resources into hierarchical queues, allowing departments or teams to have guaranteed capacity while sharing excess resources. The FAIR scheduler, as the name implies, dynamically redistributes resources to ensure all applications get an approximately equal share over time. The FIFO scheduler, which runs jobs in a simple first-in, first-out order, is useful for testing but is not recommended for production due to its lack of multi-tenancy. The resource manager's view of the cluster is built from node managers. Each node manager on every slave node periodically sends heartbeats to the RM, reporting its available resources. The RM uses these heartbeats to detect node failures. The node manager is also responsible for launching and monitoring the containers allocated by the RM. For maintenance, administrators can decommission nodes gracefully by adding them to an exclude list, allowing running tasks to complete without scheduling new ones on that node. Let's trace the lifecycle of an application. A client submits an application to the resource manager. The RM's applications manager negotiates the first container and instructs the node manager to launch the application master for that specific job. Once launched, the application master takes over, registering itself with the RM and then negotiating for additional containers to run its actual tasks. It manages the execution and fault tolerance of these tasks, while the RM provides the resources and monitors the overall health of the application master itself. YARN is built for failure. The RM's high availability ensures the resource management layer is resilient. For application fault tolerance, if an application master fails, the RM can automatically restart it, and the new instance can recover from a previous checkpoint to avoid recomputing all work. If a node fails, the RM will detect it via missed heartbeats and reschedule all containers that were running on that lost node onto healthy ones. Underlying data is saved to HDFS replication. Day-to-day administration is often done through command line tools. The YARN RM admin command is essential. You can check the service state of a resource manager whether it is active or standby using the Get Service State option. To perform a controlled, manual failover, you can use the transition to standby and transition to active commands. These commands also support a force manual option for overriding the normal process in exceptional circumstances. Proactive monitoring is key to cluster health. The Resource Manager exposes a rich set of REST APIs for this purpose. Key inputs include /metrics for cluster-wide statistics, /scheduler for key details, and /apps for application tracking. Important metrics to watch include the number of running applications, total memory allocated, and the count of containers allocated. It's also crucial to monitor the RM's own JVM metrics, such as garbage collection frequency and heap usage, to ensure the RM itself is not a bottleneck. This slide shows a sample JSON output from the RM's metrics API. You can see real-time data points like available memory in the cluster, the number of active nodes, the number of submitted and running applications, and the total number of virtual cores in use. Integrating this data into monitoring dashboards like Grafana provides a real-time view of cluster health and performance. Here are some consolidated best practices. For high availability, always use Zookeeper for state storage and deploy at least 3 Zookeeper nodes for robust quorum. For resource configuration, set hard limits on container sizes to prevent runaway jobs and use queues to isolate and manage workloads. For security, never skip enabling Kerberos authentication and enforce application master authentication to secure the entire application lifecycle. To optimize performance, consider enabling resource reservations for critical, latency-sensitive jobs to ensure they get the resources they need when they need them. Fine-tune scheduler parameters like queue weights and preemption rules to match your workload patterns. Regularly monitor node health and use the decommissioning process for planned maintenance. Finally, keep a close eye on the resource manager's JVM garbage collection metrics. Long GC pauses can manifest as application timeouts and cluster instability. The scalability of the resource manager is proven in production. For example, Expedia runs over 12,000 jobs per day on a cluster of more than 2,000 nodes, all managed by YARN. The platform's versatility is shown by its support for diverse frameworks like Spark for analytics, Test for Hive queries, and Flink for streaming, all on the same cluster. For even larger scales, YARN Federation allows a cluster to scale beyond 10,000 nodes by federating multiple RMS. In conclusion, the Hadoop Resource Manager is the sophisticated core that enables scalable, efficient, and multi-framework resource management in YARN. Implementing high availability is critical for any production deployment. Choice of scheduler allows you to optimize for your specific workloads. The future of the Resource Manager is bright, with ongoing developments in areas like native GPU support and advancements in federation for even larger scale clusters. This concludes our overview. Thank you for your attention. We now open the floor for questions.